Today's lesson is on adding and subtracting decimals, and your standard is to fluently add, subtract, multiply, and divide multi-digit decimals. Today we're only focusing on adding and subtracting, but tomorrow or on your next lecture you'll be focusing on multiplying and dividing. So don't worry, we're getting to it. For today, the only template that you have in your notebook is a small rectangle of graph paper, and that should just be pasted down so that we can use the graphing template to align up our work. So before we start, I want to make sure that you absolutely know the number one rule to adding and subtracting decimals. And for me personally, this is absolutely, positively one of the most important things you need to know. So I'm going to put a nice big number 1 here. The number one rule is you always line up your decimals. Some people like to do addition and subtraction in their heads, and when they think about it, they always think about it in a horizontal fashion. But when we are adding and subtracting decimals, you absolutely need to do them vertically so that you can line up your decimal points. Okay? So the first example, A, says 3/10 plus 9/10. And in order for me to add these correctly, I need to line up my decimal points. What do I mean by that? I mean the decimals in both of my add-ins, in addition to the decimal in my solution, all need to be in the same row. So now I can build my problem around that decimal. I have 0 and a 3, and then a 0 and a 9, and this is an addition problem. Now I'm going to go ahead and I'm going to add just the way I normally do. 3 plus 9 is 11, so I put down the 1. Is 12. I put down the 2 and I carry the 1. 1 plus 0 is 1. My answer for this problem, though a little sloppy, is 1 and 2/10. I know that my decimal is in the correct place because I made sure that I had all the decimals lined up to begin with, so there was no place for an error whatsoever. This happens in subtraction as well. You absolutely have to line up your decimals. So I'll put a decimal place, and a decimal place. I will put my solution line and write out my problems. 1.6 minus 0.8. So 6 minus 8 I cannot do, so I need to borrow from my 1. 16 minus 8 is 8. 0 minus 0 is 0. My solution here is 0.8 or 8/10, right? Let's just go ahead and mark those solutions as we go. The next problem I have is 1.74 plus 21.02. Again, I'm going to line up my decimals. And write in my problem. The first number is 1 and 74/100ths, and the second number is 21 and 200ths. Wait, here's a little bit of a conundrum. The first add-in that I have doesn't have a digit up here, so I am going to insert a 0 just to hold that place so I don't lose myself when I'm adding. Then I'm just going to add. 4 plus 2 is 6, 7 plus 0 is 7, 1 plus 1 is 2, and 0 plus 2 is 2. So my solution here is 22.76. One more problem just for good measure. Let's do some subtraction. I will insert my decimals and write my problem out. 46 and 7/10 minus 21 and 200ths. Again, just to hold the place, I'm going to insert that 0 above. So 0 minus 2 will not work. I need to borrow from my 7 and turn it into a 6. 10 minus 2 is 8. 6 minus 0 is 6. 6 minus 1 is 5. And 4 minus 2 is 2. So my final answer for that particular problem is 25 and 68 hundredths. You have 4 proof problems to solve for this particular video, and please make sure you're thorough and go ahead and use some extra graph paper if you have it. However, if you don't, be sure to line up your decimal points and create a column for each place value while you're doing your adding or subtracting. It'll help you keep track of all of your numbers without any problems.